So how many of you joined? Okay, just a second. Hi, Madhumita, Suma, Lahari, and
Hi, Prashanti.
Deepti.
Hi, ma'am.
Okay. Have you done till assignment one? Suma submitted assignment one. What about Lahari? And also I
Ma'am, a
shared
few
another
programs
section.
are pending.
Okay. So have you gone through
Um,
the assignment today assignment? So it is bit advanced questions in combinational logic circuit. Have you gone through the problem statements?
Not yet, ma'am.
Okay. Once I will explain the questions, so you can try with the coding.
Sure, ma'am.
Once you completed, I will share you the answers. Do you have any doubts in assignment one? So in assignment 2, first question is in a system where the data needs to be transferred between two variables without any intermediate storage. You are asked to swap two 4-bit values without using any temporary variable. So how will you accomplish this task efficiently in Verilog? Actually, it is swap operation. Okay, swapping means what? Suppose if A is equal to some value like 10 and B equal to 20. Okay, 10 and 20. So we need to do swap operation. That means B should get A value, A should get B value. Okay, both are interchanged. So how you are going to write the program in Verilog HDL? Actually, if you want to write this thing first, we need to understand about the blocking assignment and non-blocking assignment. Those things we will discuss in the next session. So after that, you can work on this program. Okay. Next, second question. You are working on digital calculator that needs to add two-bit binary numbers, but you also need to detect when the result overflow. Overflow means what? Carry. Will get the carry extra bit. Design a 2-bit binary adder with overflow detection and describe how you would handle the overflow condition. So first of all, how to write the program? Just addition program, and whenever we detect the overflow, suppose detecting overflow means what? A and B are 2-bit size. Okay, so we are declaring as a 2-bit size for two variables. 1 plus 1, we got output as a 2. Okay, so 1 0. 1 0 is a 2-bit. Okay, fine. Suppose 4 plus 2. What will be the value for 4 plus 2? 6. 6 means double 1 0. Double 1 0 means here it is a overflow, extra 1 bit. So you need to detect this overflow bit. So how we can detect this overflow bit? We need to write some condition. Suppose output is taken as a 3-bit. This value will be assigned to some temporary variable. Okay, some temporary variable we are assigning last third bit. Okay, of 3. Input A, so A of 3 or output of 3. This third bit assigning to temporary variable. If this temporary variable is equal to 1, then only it is overflow. If it is a 0 value, it's not overflow. Whenever it is 1, then only it is overflow. So how you can write the Verilog program and how you can detect. That is second example. Next, third one. You are tasked with designing an 8-bit barrel shifter that can shift the input data either to the left or right by a specified number of bits. The input is a 8-bit vector and the shift amount is 3-bit control signal. Already we have seen shift operation. Okay, right shift and left shift. So how you are going to shift this entire 8-bit data? We need to declare by using 7 down to 0 and 3-bit as a shift variable, temporary variable you can consider, and that variable, that 8-bit data will be shifted 3-bit times. I already shown you, right, how many times we need to shift. So you can use that example same here. Okay. Till here, any doubts? 20 questions, sir. 30 questions out there. Huh? Okay. Till here, any doubts? Next, fourth one. 4-bit adder or subtractor. We already discussed a 4-bit adder or subtractor. Same as ripple carry adder. We need to use control signal. Okay. But here some additional condition is given, overflow condition. So how you are going to report that overflow condition? That is one. Next, you are tasked implementing a single multiplier using Booth algorithm. So we have multipliers, different types of multipliers, Booth multiplication, trace multiplication. There are different types. Okay. So first you need to understand about multiplier. Then you need to implement this. Okay. And you are tasked with implementing same here also multiplier algorithm only. We will discuss multiplier and comparators, 4-bit LCD display, all these things after next week. Once you completed this assignment, then we will discuss more examples. Okay, first let you need to work on the assignments. Already we have completed all combinational logic circuits in Verilog, right? Next, 32 magnitude comparators, same comparison of addition, less than, greater than, equal to, like that. Okay. Next, priority mechanism, multiplexer, 8-bit wide, 3 input multiplexer. So 3 input multiplexer means obviously 8 by 1 multiplexer, 3 selection lines. Okay. So read the statement here and work on it. Next, Johnson counter. Johnson counter we'll discuss in the next session. Today we will discuss on sequential logic circuits. Okay. So in the sequential logic circuits in digital electronics, we already see in the flip-flops. Okay. So what is mean by flip-flop? What is mean by latch? What are the difference between flip-flop and latch? We already discussed. So these things mostly related to the sequential logic circuit. Combinedly, I have given both at a time. Okay. So these also cryptography related to sequential logic circuit only, but try if you are able to do. Okay, or else we can do in the next week also. First you need to complete 10 questions. Okay, first 10 questions are related to the combinational logic circuit and remaining we will discuss later. Okay, any doubts still here? Once you do the basic assignment, then only you can understand these problem statements. Hello.
Okay, ma'am.
Okay. Okay, fine. So in today's session, we are going to discuss how to design latch and flip-flops using Verilog HDL. Okay, so can you tell me what is the difference between latch and a flip-flop? What are the different types of latches out there and what are the different types of flip-flops out there? Madhumita, Vinita. Vinita, you have not joined the session at the starting. I just explained the problem statements, how to work on with the combinational logic circuit using Verilog HDL. Okay, just go through that and try to do the assignment.
Sure, sure.
Okay. Hi, Rakshita. Rakshita, you have some doubt regarding the tool installation, right? By end of the session, once
Yes,
let me know. Okay, don't leave the session. I will explain you
yes,
how to install the tools again. Okay.
Yes, ma'am.
Okay, fine. Um, okay, I think no doubts, right? So today we will discuss on how to write the program for sequential. So before writing sequential logic circuit, in combinational, however, we have written some design and the test bench. Same here also we can write design wise, it's same. If you are writing behavioral modeling in the procedural assignment statement in combinational logic circuit, we have used always at the rate of star. That means the input values are changing with respect to the output values are changing with respect to the input star. Okay, but in sequential logic circuit we will mention always at the rate of pause edge clock or negate clock. If you want to change the output with respect to the positive edge of the clock, then you can put pause edge clock. If you want to change the output with respect to the negative edge of the clock, then we can put as a negate clock. Okay, or pause edge resetter. So most of the interview question, this is what mostly asked questions in the interview. What is the difference between synchronous and asynchronous reset? Okay, so synchronous means in terms of coding I am telling. uh, Normally in digital logic design, what is meant by synchronous and asynchronous? Veena, Sai, Sunny, what is the difference between synchronous and asynchronous?
Synchronous means it match the input matches. The output clock matches with the input clock. So we will have same uh, same
Mhm.
time period or frequency of the output signal. And
Oh,
asynchronous means we don't have a clock.
we don't have clock, then what we have
Yes.
in asynchronous instead of clock? Hmm?
No idea.
Okay, so what is the difference between asynchronous and synchronous means? Suppose there is a counter, there is a 4-bit counter. 4-bit counter means the four number of flip-flops will be connected one to one. Okay, so here if it is a synchronous counter or asynchronous, synchronous means clock would be common for all. Okay, this is what the common clock. If any small change occur, the value will be triggered to each clock. All circuits will be work with the same clock, triggered at the same time. Okay, so synchronization will be there with entire circuit, even not only the four counters. These counter we are connecting to some FIFO logic. The FIFO logic is going to connect with some synchronizer or any some other blocks. So within all the blocks, there will be proper synchronization. All will be activated at a time. Okay. But asynchronization means output of one circuit will be connected to the input of another circuit. Here, output of one circuit will be connected to input of another. Here, clock. Okay. So this is what the input of clock here. That means this clock is dependent on this output, and here this clock is dependent on second flip flop output, and here also it is dependent on third flip flop output. Okay, so there is no proper synchronization between all these. Depending on one circuit is depending on another one. Okay, so mostly in asynchronous circuits we'll get the glitches and hazards. Okay, um and also we do not able to have proper timing because all are asynchronous dependency, and also we don't get output at same time. Okay, until unless it generate the output, this circuit will not be activated. Until this generate the some output, this circuit will not be getting activated, right? So that is what major issues we'll see. But we have both kind of circuits, asynchronous circuits and synchronous. In industry mostly we will prefer synchronous only. Okay, not asynchronous. Those are like old style. Suppose we have a protocols. Okay, most used protocols like every student must learn, like UART protocol, I2C, APB, AHP, AXI, AMBA protocols. Okay, UART protocol is asynchronous. Here we don't use any clock. It is asynchronous in nature. Because of asynchronous, we have lot of limitations with the UART protocol. Okay, but coming to I2C protocol, it is a synchronous. We use the clock between input and output. Okay, so there will be a lot of advantages with synchronous clock, like AMBA protocols. All are synchronous only. No one is asynchronous. Okay, but your protocol is a very old style. By using the baud rate, we make it synchronization, but there will be lot of limitations. Okay, so this is what the difference between synchronous and asynchronous. Okay, so how we can show that thing in the program, in the sense, this line, just a single line we need to write. If there is no reset here, that's what we call as a synchronous. If there is a reset here, asynchronous. Okay, asynchronous means whenever the input changes, automatically the output change. Whenever the reset is high, automatically the output will be changed. It doesn't check whether the clock is active high or active low or edge trigger, active high edge trigger or level. It doesn't check for anything. Whenever it is high, the output will be triggered. That's what we are calling as a asynchronous. Okay, so that's why we are mentioning it in the design block. Okay, so that is what one difference in design part. Coming to the test bench, in combinational logic circuit, we don't have any clock. We already designed lot of examples. Multiplexers, hierarchical multiplexer, ripple carry adder, full adders, decoders, encoders, priority encoder. So everything got how to design and also how to write the test bench. Okay. But in sequential logic circuit, we use a clock. Majorly, we use clock. I already shown you how to write the clock program also. Okay. So once again, I will write and I will show you how many ways we can write. I just shown you using always block only. Okay. But not only using always block, we can use forever, repeat, for loop. Okay. There are a lot of ways. So whenever we are writing the program for sequential logic circuit, the clock is very important. So how to write the clock? Module, name of the module, and I am declaring clock as a CLK. Okay, so initially I'm taking clock as a 0. Why? Because the clock should be like this. You already know, initial block execute single time, always block execute multiple number of times, iterations, until unless we stop the execution or we stop the simulation. Okay, so that's why we are making initially clock equal to 0. Okay, after some delay, after this time of delay, again I'm making clock as a 1. After this much of delay, again 0, again 1, 0, 1, 0. So how much the clock period? Clock period will be from here to here. Positive edge or negative edge. Edge to edge. Okay. So suppose here it is a 10 time unit. 10 nanoseconds. Okay. As of now, I won't discuss regarding the nanosecond or picosecond like that. Okay. In the coming sessions, I will tell you how to put nanosecond or microsecond, picosecond. As of now, I just mentioned 10 units. Okay, because if you want to mention in these terms nanosecond or microsecond, we need to write the time scale. Okay, that thing we will discuss in the test bench concept, verification concept. So 10 units, 10 units in the sense, suppose it's a on period, on time and off time. So on time will be 5 time units, off time will be 5 time units. So every 5 time units, it is toggling. Toggling in the sense, uh, 10101010 complement. Okay, so we can write the program always hash 5 time units, clock should be complement. Okay, so how we can write in the program? Always is one of the procedural block, as you know. Hash 5 clock equal to not clock and then end. Simple program. We no need to write the big end. Okay, because we are not using any multiple statements. Okay, but if you want to print this clock value in the output side, or even if you want to open the waveform, we need to write either dollar monitor or simulator directives system task, right? So for that purpose I am writing initial begin dollar monitor time, also simulation time, clock equal to clock, same as a printf statement, and dump file, dollar dump file to open the waveform. Here actually dump file we need to put dump.vcd or design name. Here I am not writing any design name. Okay, so if I write right side a design name, I can put the design name .vcd, but here I'm just mentioning like the next dump wares. Dump where in the sense whatever the variables are there here, we are dumping into the waveform end module. Okay, so this is how we can generate the clock program. Select the tool and here click on open EP waveform. So once you open EP waveform, according to this dump, suppose I am removing this dump. Okay, I have removed this dump and run. It doesn't open the waveform. It will give some, it throw some error. Reached maximum limit 5000. As you already know, always block is execution, like number of times it iterate, number of like we don't mention any stop signal or any to terminate the clock. Here we didn't give any system task here, right? So it keep on running till automatically it reach maximum limit, so automatically the process will kill. Okay, but all these things are wastage, right? 24825 simulation time it is repeating, but that is not required in the simulation. Okay, so these all are not required. If you see, lot of times it got iterated, so these all are not required. Okay, for this purpose we need to use a dollar finish. We will stop at some particular time, the execution will be stopped. And also if you see, okay, first I will write the dollar finish. Suppose I want to generate only 100 time units. Okay, after 100 time units automatically the system will go to terminate. So dollar finish to terminate the loop. Okay, see, after 95 time unit, after reaching 100 time unit, automatically it getting stopped. At 100 time unit, dollar finish is called. Okay, so we will discuss what is meant by dollar finish, dollar time, dollar stop in the verification now time concepts. Okay, if you see here, at 0 simulation time, clock equal to 0. At 5 simulation time, clock equal to 1. At time 10 simulation time, clock equal to 0. So 0 1 0 1 0 1 0 1. But I need to check this thing in the waveform. For that purpose, I need to generate the waveform. See, here I just click on open waveform, but not opening the waveform because we didn't write dump file and dump variables. Dump var. Okay. So here, just write this. Now run. Okay, see waveform. How the waveform is generated? Initially, 0 because initially we have written as a 0. Initial clock equal to 0. And then after 5 time units, clock is iterating. So 0, next 1, 0, 1, 0, 1, 0, 1, 0, 1. So this is how we can generate the clock. Every 5 time units it is changing. See, till here 10, 20, 30, 40, 50, 60. So every sequential logic circuit, even it's a flip-flop or register, counter, memory, finite state machines, whatever we need to use this clock. Very simple. Just these 3 lines you need, 2 lines you need to mention. Okay. Any doubts still here?
Ma'am, one doubt, ma'am.
Mm.
If we use dollar display instead of monitor means our clock won't be
Mm.
generated, correct?
Mm. Yes. What is
Okay.
the difference between dollar display and dollar monitor?
Dollar monitor means at each change we will display the output, but dollar
Okay.
display it will display at the end.
Okay. At the end,
I mean,
at the end,
uh,
at the end,
yes,
what is
ma'am.
at the end?
At output, ma'am. Last output it will display. But monitor means for each change it will display.
Okay. Then what about the dollar right and the dollar strobe? Dollar right and dollar strobe.
Well, no idea, ma'am.
Okay. Actually, we will discuss these things in the verification concept, but as you got the doubt, I will explain. Dollar display means not at the end of simulation. Dollar strobe means at the end of simulation. Dollar display means immediate value. It print immediate value. Dollar monitor means it checks for it monitor every value, and whatever the change in the input is there, every value it will be displaying in the output side. Okay. Suppose here always at every 5 time units the clock value is changing for every 5 time units. Okay, so whenever you write a dollar monitor, then every 5 time unit whatever the change, even it's a 2 time unit change, or see at 1 time unit whatever the change is there, every change will be printed at the output side. Okay, but in same place dollar monitor I am writing dollar display. Here dollar display means it won't write every change whatever the before value is there before the dollar display, only that value will be printed. Okay, so here what is the before value? Clock equal to 0 and clock is updating with the 1. Okay, that value only printed clock equal to 1, it will be printed only that value. Okay, even it doesn't print this clock equal to 0 because immediately it is changing the value. After this statement only we are writing the dollar display. That is one case, or else initial blocks will start execution at a 0 simulation time. All initial blocks will start at 0 simulation time, right? So at 0 simulation time this clock equal to 0 is executing. Immediately this initial state block will be executed. So obviously I think this display statement will be executed at 0 simulation time. That means this clock equal to 0 will be printed. There is no chance to print this clock equal to 1 because it is executing at a 5 time unit at 5 time simulation time. Okay, so if you check the output, maximum we will get this output only, clock equal to 0. See, clock equal to clock equal to 0, only it is printing. Okay, suppose if I write same display statement after this always block, then clock equal to 1 will be printed. Okay, but it will not print always clock equal to 1 0, it won't print like that. Okay, so Just run and check. Okay, here we need to write multiple statement, but in this case it will repeat. Yeah. Okay, first let me show the difference between display, then I will execute this one. Okay, so initial clock equal to 0. This display statement I'm putting here, and also I'm making clock equal to 1 at a 5 time unit. So here also I'm putting dollar display, and next hash 1 clock equal to 0. After this 0 I am not printing any dollar display statement. Okay, next after 4 time unit clock equal to 1. After this I want to put this dollar display statement. Okay, now what is the output? Any guess? What is the output? So this clock equal to 0 will be printed. This also printing, but this 0 will not print because after that we didn't put the dollar display, but this will be printed. Okay, check run, run and check the output. See, 0, 0, 1, 1. Only three statements of printing. 0, 1, 1. Okay. So if I put this same dollar display statement after this 0 also, then this 0 also will be printed. See, 0, 1, 0, 1, 0, 1. All four are printing. So whatever the statements you want to print, every time we need to write the dollar display, dollar display, dollar display after every statement. Okay. But I am removing all these dollar display statements. I will put only single monitor statement. So every state it will be monitoring and print the value. I'm just removing all dollar display statements here. Okay, monitor. Now run. So all these values will be printed by using single dollar monitor statement. See, 0, 1, 0, 1. Okay, no need to write those many display statements. Understood clearly?
Yes, ma'am.
Okay, others?
Yes, ma'am.
Okay, so that is how we can generate the clock by using always block. Okay, so next, not only by using always block, there are a lot of ways to write to generate the clock. So here initially clock equal to 0. I have commented this, right? We will try this also. I think here it will generate multiple number of times dollar display because we have written within the always block. So always block will be repeated number of times. So dollar display also will be repeated number of times, right? We'll see what will be the output. Correct. See, dollar display also will repeat number of times because of always block. But if you write within the initial block, this dollar display will be printed only one time. Okay, clear till here? Rakshita, is it clear?
Yes, ma'am.
Okay. Next, so I want to explain how we can use in different ways for by using repeat and always. Okay, how to generate the clock in some more ways. So if you see here, by using the repeat block, there are some more loops like while, do while, for loop. So we will discuss that thing later. So how to use the repeat? Repeat means what? Okay, I won't explain now. See here, module, ret clock, initial begin, clock equal to 0, 100 times repeating, hash 5, clock equal to not clock. Okay, so forever. Initially clock equal to 0, clock equal to 0, forever, hash 5, clock equal to not clock. At 100 time unit, dollar finish. So what difference you are observing between repeat and forever? What is the difference? What is the difference between repeat, forever, always?
In forever, we are giving the clock in 1 bit. I mean binary bit 1 and 0. But
Here
in
we are
always, we have given direct.
here in repeat block. Are we not giving clock as a 1 bit, or even
Yes, we are giving.
by using always block here?
In here, we are giving the directly as 0 and negative clock, right? There we are giving the bit.
Both are same.
Yeah, because see, but repeat till we have given 100 times repetitions like that we have given, and here
Okay. Yeah, that's
Ma'am,
correct.
is it repeat? Oh,
Tell.
oh no, ma'am. I thought wrong.
No problem. Tell.
Repeat means repeating the same value,
Mm,
right? And
mm.
forever is the toggling, correct?
Okay. Here it will not toggle.
Yeah, ma'am. Here also,
So in
but
repeat,
here,
dollar finish is not used, right? And
Mm,
in forever, it I think it executes till it uh, finds dollar finish.
okay, fine. What is the difference between forever and always? In always block also, it is a iteration. Number of times that the block will be iterating, and also we use the external system task to stop the execution like dollar finish. Here also we are using dollar finish. Then what is the difference between forever and always?
Forever is used in initial begin block.
Okay.
Mm.
Others, Sunny, Sai,
No idea.
Veena. Sunny, do you know Verilog HDL?
Yeah, ma'am, little bit.
Okay. What about Sai Kukunri?
No, ma'am, I'm new to it.
Okay. Veena?
Yeah, I have basic understanding.
Okay. Fine. So repeat somewhat you reach. Okay. Repeat means fixed number of times. 100 number of times means the loop will be repeated 100 number of times only. 10 number of times means 10 number of times only it will be repeating the entire loop. Whatever we written in that, it will repeat. Like for loop. Okay. For I equal to 0, I is less than something we already written, right? So like for loop, it will be used. Okay. But repeat loop, we no need to use external system task like a dollar finish to stop the execution. Okay, so it repeat fixed number of times, automatically stop the execution. But by using forever, it is a keep on executing only, like always block. Okay, to stop the execution, we need to use either dollar finish or dollar stop. Okay, same always block also same. But what is the difference means always block is synthesizable. We can write in a design also. But for loop is not synthesizable. We cannot write in the design. It is only for simulation purpose. Only we can write in the test bench only. Okay. So that is what the difference between always and forever. Same here. I am removing this always. I am putting forever. No need to write begin. Okay, so run. Wait, I'm removing this dollar finish also. Undefined module in 11th line. Okay, forever we need to write within the initial block. Just I didn't written anything. So here I'm mentioning inside the always block, initial block. So run. Or else directly we can put in same block also. No problem. Anything is same. I didn't written dollar monitor statement, I think. Okay. So that's why output is not printed. Dollar monitor time. Long simulation. Still it is running. We didn't use finish, right? That's why. Forever is a long execution time, but always block will see. Execution interrupted or reached maximum runtime. Even it is not printing the output also. But by using always block, we got output after reaching maximum limit, automatically it got stopped. Okay, but for loop, we are not getting even output. Okay, I'm just using dollar finish at 100 time units. So here it will be printing till 95 time unit. Reach maximum limit again. Oh, sorry. Not forever, for each. Here also we kept for only, yeah, not forever. Syntax error. Okay. Both we in Verilog we have both forever and for each also. $time clock equal to binary format clock. Maximum time reached maximum time. So If you see here, reaching maximum time, dollar finish also we used. Okay, I will check this thing later. Always. Okay, within the initial block, we cannot write the always block. So that's why you're getting the error. So this dollar stop also we need to write within the always initial block. Okay, for always block, it is getting correct only. Forever block, this 100 time units is not getting. I will check that. And by using repeat block, we need to write dollar monitor here also. $500 time units. That means it is repeating 100 number of times. So here we didn't return any external termination like dollar finish or dollar stop. We didn't return anything. After repeating 100 time units, automatically it will be stopping the execution. Okay, or else if you want to check simply, you can just put 10 number of times. So after repeating 10 number of times, clock equal to 0, clock equal to 1, clock equal to 0, clock equal to 1, like that 5 cycles, we will get 5 cycles. 10 number of times repetition means. Okay, what is this? Repeat 10. Okay, repeat 1 is getting correctly. So this clock equal to 0 is printing, and clock equal to not clock. Only one time it will be printing. Okay. So after that, automatically it stop the execution. Suppose I am putting 10 again. Okay. Now it is printing 10 number of times correctly. Okay. So if you want to check the waveform, write the waveform here itself. I'm taking another initial block, initial begin, dollar dump file, dumping the waveform, dump.vcd, next dollar dump wares end. So now it will open the waveform. Okay, see how it is printing. Repeat of 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is how it will printing. Clear everyone how to generate the clock? Any doubt still here? Forever loop I will check again. Hello,
Yes, ma'am.
Lucky, Veena, Suma, Madhumita, Sunny, Vinita, Sai.
Yes, it's
Yes,
clear.
yes, Prashanti.
Okay, fine. So now we'll check how to design a flip-flop. Okay, so what are the different type of flip-flops are there? SR flip-flop, D flip-flop, JK flip-flop, T flip-flop. We already seen why we are getting invalid condition in SR flip-flop, how to avoid the invalid condition, and how we are going to get a D latch. And JK flip-flop, how we are getting the race around condition in toggle, and how we are going to avoid the race around condition by using the flip-flop, and how we are getting the toggle condition, and also toggle flip-flop, T flip-flop finally. Okay, so we can design all these flip-flops using behavioral modeling because we already have the truth table, right? Okay, fine. So we already seen how to design the truth table and output circuit diagram, and also in gate level, right? So by using the behavioral modeling, if you want to write using the behavioral modeling, we need to use the truth table. That means positive edge of the clock, what are the inputs? S or the inputs, Q bar or the outputs. So in behavioral modeling, we can write either if else or case. So if 0, 0, then what is the output? If 0, 1, then what is the output? Else if 1, 0, then Q equal to what is the value? Else if 1, 1, default case else, then what is the value? This is what by using the behavioral modeling. Data flow modeling, output expression. So after drawing the truth table, you will be getting output expression. Directly we need to put that output expression. In gate level modeling, from output expression, we'll get the gate level circuit netlist. You already know how to write the program. Okay, I will tell you all these models. Every flip flop one model we can discuss. Okay, remaining you can practice. Okay, so for flip flop 4 models we can discuss. First flip flop will be SR. Okay, first SR flip-flop. In behavioral modeling, okay, so how to write in behavioral modeling? First module, name of the flip-flop, SR flip-flop, input S or clock, here like reset, clock and reset signal, output Q1, okay, and all inputs are declaring S or clock reset. Next output also declaring here using rich data type. Why? Because we are using the always block here, okay, and initial begin Q equal to 0 initially. Actually, we need not to mention initial block in the design. Why? Because initial is not synthesizable. It is only used in the test bench. Okay. But here we are just initializing Q equal to 0. That thing you can write left hand side also. But why we are using here means I will explain. So this is optional. And then always at the rate of POSIX clock. Here it is a synchronous. If it is asynchronous, we need to write reset also. Mostly asynchronous we use in counters, registers only, not in all circuits. Okay. So begin if reset is active low. If reset is equal to 0, case. Here we have used case. You can use case or if else also. Okay. So case SR 2-bit binary 00, then Q equal to Q, memory state. Okay. So we have a condition. Whenever we are using a Q in a procedural assignment statement, it should be declared as a range. Right hand side variables must be declared as either range or wire, right? So we need to follow here. So 0, 1 equal to, then Q equal to 0. 0, 1 means Q equal to 0. 1, 0 means Q equal to 1. Okay. Like that, 1, 1. 1, 1 means it's invalid. Why do we get the invalid? Because Q and Q bar must be complement. If Q is 0, automatically Q bar should be 1. If Q is 1, automatically Q bar should be 0. But in invalid case, both values we will get as the same. You can I have shared the digital PPT, right? Just go through that and put the value and check. Both we will get same value. That's why we will call it as a invalid. Okay. So unknown case. So here X. This is for Q. But what about Q bar? We need to write for Q bar also. So here end case else and Q equal to 0, Q1. Q1 is nothing but Q bar, not Q. Whatever the Q value is there, opposite, complement for Q1. So that's why we are just putting as a complement. Okay. So this is how we can write in a behavioral modeling. Or if you want to write more simple, we can write another style also. Okay. So this is what the test bench. I will explain test bench later. Coming to the JK flip-flop, is it clear everyone? SR flip-flop?
Yes, ma'am.
Any doubts? No?
Prasanthi, RE is a reset?
Yes. Any doubts, others? Sai, Sunny, Veena?
No, ma'am.
No.
Okay. So coming to the JK flip-flop, here is another case how you can write some more simplified way. Behavioral only, but some other style. So module JK name, JK or the input, reset, clock, Q bar. Okay. And inputs are declared JK, clock, reset, and output also declared QB. Okay. Always at the rate of POSIX, clock, begin. If reset is high, then begin case JK. If JK is 00, then Q equal to Q. JK equal to 01, Q equal to 0, reset state. If JK equal to 10, q equal to 1, set state. If j equal to 1, k equal to 1, then toggle case. Okay, so q equal to q bar. Okay, this is how we will mention as a toggle. Next end case, qb equal to q bar, complement of q. Okay, every always statement qb equal to q bar, q bar. Okay, next else, in else case is very important. Okay, why? Because if you don't mention else case, we'll get the latches. Latches is also one separate topic. We will discuss about the latches later. Okay, so this is somewhat simplified way. If you don't want to use this case, we can also use if else. Suppose I'm writing if j comma k, concatenation operator, equal to 0 0, then q equal to q, else if jk equal to 0 1, then q equal to 0, else if one 0, then q equal to 1, else default q equal to not q. Okay, so this is how we can write in if else also, if you want to write. Both are behavioral modeling only. Okay, clear till here everyone? Next, D flip-flop. D flip-flop, very easy. Just q equal to q in one whenever 1 is high. Okay, so this is another style where we can use both continuous assignment statement and procedural assignment statement within the same module. Okay, so if you see here, module D flip-flop, clock comma reset D Q Q bar, input reset DQ, output Q Q bar, and assign Q bar equal to not Q by using continuous assignment statement. Initially, we are just assigning Q bar equal to not Q. Okay. Always at the rate of POSIX clock and POSIX reset, asynchronous reset. Begin. If reset is high, Q equal to 0, else Q equal to D. You already know. 0 means output will be 0. 1 means output will be 1. This is for D flip-flop. Okay, D flip-flop is nothing but storage device. We mostly use it for storing the data. Toggle is for toggling clock. It counts number of clock cycles, right? So that's why for registers, what is meant by register? How many bits will be stored by a flip-flop? How many bits will be stored by using flip-flop?
1 bit.
One
One
bit.
bit.
So if we want to store multiple number of bits, suppose I want to store 4-bit data. So which type of circuit I need to use to store 4-bit data?
4D flip-flop.
4D flip-flop, which are connecting in a sequential manner. That's what we calling as a register. So here 4 number of flip-flops one on one will be connected. So this is what we call as a 4-bit register. Okay, so if you want to design a 4-bit register in Verilog HDL, there also we can use either behavioral modeling, data flow modeling, gate level modeling, or structural modeling. In structural modeling, already we designed a replicatory adder, hierarchical multiplexers, hierarchical demultiplexer, right? In the same way, we can design the shift register also. In the next sessions, we will discuss right shift left, serial in, parallel out, parallel in, parallel out, serial in, parallel in, serial out, parallel in, parallel out, bidirectional, universal shift registers. So every design I can show you in different styles. Okay, so this is how we can design a single D flip-flop. Okay, clear everyone
Uh,
till here?
Prasanti, one small doubt I have,
Mhm.
because I forgot this concept of this asynchronous reset. Like how I mean, how we are telling this is asynchronous reset here in this program.
Here we are mentioning reset separately. Okay, so here reset separately means what? If I don't mention reset there, if I remove the reset here, if I am removing the reset here, this output will be dependent on only clock. Okay,
Clock,
so
yes.
whenever the reset is high, this reset also depending on the clock only. Suppose initially the clock is like this. Suppose if I am using synchronous reset, reset is high at this point of the time. Okay, at this point of the time. If it is a synchronous reset, this reset will not automatically reflect to the output. It wait until next to positive edge of the clock. Then only the reset will be reflected to the output. Then output goes to 0. Okay. But asynchronous reset means whenever the reset is high, it doesn't check for the clock because it is not synchronous. It no need to wait till clock getting next edge. So automatically this reset will be reflect to the output. At this point of time only output will go to 0.
Okay. At
Okay,
zero
clock
time.
means what? Not only reset. If A, B value are changing, here A, B value are changing. Even this value changing, these two values need to wait until next positive edge of the clock. Then only output will be changed. But if it is a latch, no need to check until next positive edge of the clock. No need to wait. Automatically those outputs will be reflected. That is what the difference between latch and a flip-flop, right? We already discussed there will be no proper controllability on the output. Whenever the input changes, automatically output changing. So that's why we'll get the race around condition. Okay, same asynchronous also same for reset. Okay, next T flip flop. T flip flop here how we are writing using output expressions. Draw a T flip flop diagram. You will get a circuit diagram like this. I will show you what is the circuit diagram of this T flip flop. Okay, gate level. So by using that circuit diagram, we need to write these statements. Not gate level, it is a data flow modeling. Okay. Anyone have doubts to use this quarters prime? No doubts, huh?
Prashant, in this, if we want to write another program, I mean one Verilog program and another one Verilog program for compilation, it is not working for me.
You need to select that particular design here and need to come
Yeah,
here. You need to select which design you are compiling.
yeah, that only it is not coming showing for me. So
Okay, I will check.
yeah, thanks.
Okay, see here. Here NOT gates will generate separately. Maybe you will get some confusion because we are writing the NOT gates also separately here. Okay. But instead of this, if you write the gate level modeling, you will get a proper circuit diagram. Here we didn't written in terms of gate level, just in terms of circuit diagram we have written like this. Okay. I will show you in gate level also. Once work on this, okay. In the next session, we will discuss on gate level. Suppose serial in parallel out. Structural modeling. Serial in parallel out. Serial in serial out. Few only I written in structural modeling. I have covered all models parallel in serial out. This is also not structure. Okay. Serial in parallel out only I have written in structural. So I'll show you the synthesis of this and also simulation we'll see in the next session. Today I will share you all combinational logic circuits examples. I didn't share right all the codes. See, structural modeling. Which example it is? Serial input, parallel output. How do we get the serial in parallel out? Like this one diagram, second diagram, third diagram, fourth. So this is each D flip-flop. We need to write one D flip-flop. We need to take the copies of 4. So we did same here. 20th line. How to write the D flip-flop? Very easy code. If clear is high, output equal to 0. Else Q equal to D. By using this copy of a D flip-flop, we created 4 number of flip-flops and making the connection here. You already know, but I will explain in the next session clearly. So this is how we'll generate the 4 flip-flop. So serially inputs are giving here, but output is getting parallelly here. Okay, so how do you will observe the output means we need to do the simulation. This is just synthesis. GABA. GABA. Okay, see here. These are the flip-flop. Okay, 4 number of flip-flops. This is what we call it as a shift register. And here is the test bench. We can do the simulation later. First, we will complete for flip-flops. Clear, everyone, till here? See, what is S or reset is high, so output is 0, and S is 0 or is 0, output is same 0. S is 0 or is 1, output is going to reset state because reset is high. S is high, or is 0, set state, so output is going to set state. S is 1, or is 1, output is going to invalid state. Okay, so this is how we write for SR flip-flop. Test bench is also given here. Okay, and JK flip-flop, D flip-flop, T flip-flop. Take time, check the output, observe the output whether it is getting correctly or not. Okay, clear? Everyone till here today's session? Any doubts? In the next session, we will discuss clearly into remaining simulations of flip-flops and shift registers. After shift registers completed, blocking, non-blocking assignments, latches, small topics are there. That will be one session. And next week, counters. Okay. Okay, so remaining all can give the session. Suma and Rakshita have doubts in tool, right? So remaining all can give.
Will you be sharing this recording?
Yes.
Okay. So through email?
Yes.
Okay. Okay, thank you.
Thank you all. Remaining Lahari,
you.
any doubts? Vinita, Sunny, Sai. Okay, fine.
No, till
ma'am.
now. I'll do the assignments and will let you know.
Yeah, sure. Rakshita, can you share your screen?
Ma'am, I'm not attending in laptop, ma'am. In mobile only I have attending.
Mhm. Okay. Then Sumalata will guide you. Okay. Whenever you are
Yes,
free, tell to her. She will guide you how to install the tool. Okay.
okay,
Yeah,
ma'am.
sure.
Okay. Yeah, you can share your screens, Sumalata.
Yeah, Prashanti, are you getting my screen?
No.
I'm trying to share, but it is not getting.
Okay. Okay, no problem. Tomorrow I can check. Or else you can put the screenshot. I can check.
Sure, Prashanti.
Okay. Okay, then thank you. Bye.
Oh,
Yeah,
thank
bye.
you, ma'am.
Thank you.